A buffer overflow attack is one of the most common and dangerous security vulnerabilities in computer systems. It happens when a program writes more data into a buffer than it can hold. The extra data can overwrite adjacent memory locations, leading to unexpected behavior, system crashes, or execution of malicious code. What is a buffer? A buffer is a temporary memory location used to store data while it is being transferred or processed by a computer system. It is an intermediate storage area between different components such as processor, memory, and input or output devices. Buffer helps in managing data efficiently by holding it until the system is ready to use it. For example, when a user types data using the keyboard, the input is first stored in the buffer before the program reads it. Similarly, when data is read from a file or received from a network, it is stored in a buffer before processing. In programming language like C and C++, character arrays are commonly used as buffers. What is buffer overflow? A buffer overflow happens when a program stores more data in a buffer than it is located cells. Since every buffer has fixed amount of energy, it can hold only a limited quantity of data. When this limit is exceeded, the extra data flows into nearby memory locations that are not meant to store it. As a result, important memory areas such as variables, function pointers, and return addresses may get overwritten. This can change the normal behavior of a program and may cause unexpected results or system crashes. Types of buffer overflow. Basically, the buffer overflow is divided into stack-based attacks, and heap-based buffer overflow. Stack-based attacks. The stack-based buffer overflow occurs in stack memory, which is used to store function calls, local variables, parameters, and return addresses. When a program writes more data into stack buffer than it can hold, the extra data overwrites nearby memory locations on the stack. Heap-based buffer overflow. A heap-based buffer overflow occurs in a heap memory which is used dynamic memory allocation during program execution. The heap stores data that is created using functions such as malloc, calloc, and new. In the attack where more data is written into heap buffer that is allocated size, the extra data overrides adjacent memory blocks. This can corrupt important data structure pointers and control information stored in the heap. Example of a buffer overflow. Here is the code which is given for the buffer overflow. How attackers exploit buffer overflow. Attackers exploit buffer overflow vulnerabilities by reliability providing very large or specially crafted input data to a program. This excess input exceeds the buffer storage capacity and overflows into nearby memory locations. Prevention techniques. Preventing buffer overflow attacks, programmers should use safe functions that limit the amount of data that entered into a buffer. For example, functions like fgets and scanf with proper format specifier should be used instead of unsafe functions like gets. The safe function helps ensure that input does not exceed the buffer size. Programmers must also perform proper bounds checking before it. Thank